So, what if I told you that the underlying code used to beat, like, a 1980s Atari game? Turned out to be the exact same key needed to decode human biology.
Yeah, it sounds like science fiction.
Right. But it's actually predicting the shape of basically every protein on Earth and potentially curing diseases like Alzheimer's. So for today's deep dive, we've got a massive stack of sources centered on this one singular figure, Demis Hassabis.
Right, the head of Google's AI empire.
Exactly. A guy Stephen Hawking actually called one of the smartest people on the planet.
Yeah.
And the mission for this deep dive isn't to look at scary code or, dense academic papers. The goal here is to cure your AI anxiety.
Which I think a lot of people have right now,
Oh, absolutely. But if you can understand the philosophy driving this one specific person, you basically get the ultimate shortcut to understanding the entire trajectory of artificial intelligence.
Yeah, and the central theme we really pulled from all these sources is that Hassabis operates, well, entirely outside the standard Silicon Valley playbook. He's not trying to optimize an ad network or build the next trendy consumer app. He is a scientist who is playing an infinite game.
Yeah.
I mean, the chatbot wars we see in the news, that's just a byproduct of his actual goal.
Which is cracking the fundamental source code of reality itself.
Exactly.
And when you look at the sources, they detail this origin story that just perfectly explains that massive drive. We are looking at a child prodigy in the absolute truest sense of the word.
Oh, for sure. I mean, by age 4, he's watching his father and uncle play chess, and he masters the board in just a matter of weeks.
Weeks at 4 years old.
Right. And by 13, he is an international chess master. He was actually ranked second globally for players under 14.
Trailing only the legendary Judith Polgar, which is just insane.
Yeah, so he was deeply embedded in this highly competitive 64-square world. But then there's this turning point in his life. He's just 11 years old at a tournament in Liechtenstein. And he's watching this Danish master who has just finished this grueling 10-hour match, just completely exhausted. And the sources describe Hassabis looking around this room packed with brilliant minds, and, well, he feels a physical sickness.
See, I found that reaction so fascinating. I'm like, why is sick? I mean, competitive chess is usually celebrated as the pinnacle of human intellect, right?
Yeah, but he saw it as a closed loop. He realized that all of this incredible human brain power was basically being poured into this artificial, totally constrained environment.
Oh, I see.
It was contributing absolutely nothing to the real world outside that tournament room. So to him, dedicating a genius-level intellect to just a board game was a tragic waste of potential.
Wow.
And he actually forfeited his own match immediately.
He just walks away, and he pivots straight into programming.
Yep.
He gets his hands on this 1984 book by David Levy. It's about chess computers. And it essentially teaches him how to digitize physical space. You assign positive numbers to black pieces, negative to white pieces, and you run algorithms like Minimax.
This is such a classic algorithm.
Yeah, and mechanically, it's a decision rule where you look at the board, assume your opponent is going to play the absolute most punishing move possible, and then you calculate your sequence of moves backward to minimize that worst-case damage.
Right, planning for the worst.
Exactly. And by 12, he codes an Othello-style game called Active Fish, using this logic just to beat his 5-year-old brother. But the real leap from board games to simulating reality happens at 15.
When he joins Bullfrog Productions.
Yes.
So this is the early 90s, the era of this simulation game called Theme Park. And you have to remember, the hardware constraints back then were just severe.
Oh, yeah.
Computers had maybe 4 to 8 megabytes of RAM total.
I mean, you can't even load a modern text document with that.
No, not at all. And yet Hassabis was tasked with building the artificial intelligence for every single non-playable character visiting this digital amusement park.
It's wild.
He had an allowance of just 200 bytes of memory per character. And within those 200 bytes, he had to store complex state machines, tracking their hunger, their happiness, their nausea levels, based on the physics of the roller coasters they just rode.
Think about the compression required there. It's like packing for a month-long trip using only a tiny fanny pack. It's not just about making the code small. You are literally mathematically distilling the core drivers of human behavior into a tiny sequence of bytes.
Yes.
You're deciding what information is absolutely essential for life to function.
And the execution was flawless. I mean, the characters reacted dynamically to the park's changing conditions, creating a genuinely simulated, functioning society.
Right.
There's actually an anecdote in the sources where he shows this to a Carnegie Mellon professor at an AI conference.
Oh, right.
And the professor literally jumps out of his chair in shock.
Because it shouldn't be possible. But mastering video game AI eventually reveals a ceiling for him because he starts his own company, Elixir Studios, and builds this hugely ambitious political simulation game called Republic, the Revolution.
Right.
And the lead programmer on that project, David Silver, ends up completely overwhelmed by the sheer complexity of it. Hand-coding thousands of if X happens, do Y rules just creates a brittle system. I mean, it doesn't scale.
No, because hand-coding rules is a dead end for general intelligence. The real world just doesn't operate on fixed, predictable scripts, you know?
Right.
So Hassabis realized that if he really wanted to build a machine capable of learning anything, he had to study the only existing proof that such a system was even biologically possible.
The human brain.
Exactly. He went to University College London to get a PhD in cognitive neuroscience.
And the sources show an insane work ethic during this period.
Mm.
I mean, he's running a company, taking meetings all day, and then doing a second shift of deep academic research from 10 p.m. to 4 a.m.
It's unbelievable.
But this is where the philosophical foundation of modern AI is really forged.
Yeah, he was heavily influenced by the book Gödel, Escher, Bach. The core thesis there is that simple, cold, local elements like a single ant or a single neuron in a human brain are entirely devoid of consciousness on their own.
Right.
But when you network millions of them together, the structure itself creates complex meaning. The intelligence essentially emerges from the architecture.
And the sources also point to the philosopher Immanuel Kant, who argued that reality is essentially a mental construct. Like, we don't interact with the universe as it truly is. Our brains just process sensory signals and render a localized version of it.
Which brings Hassabis to his ultimate conclusion, really. That information is the fundamental unit of reality.
Okay, unpack that.
So if you zoom in on a solid table, past the wood, the molecules, the atoms, the quarks, all that remains are mathematical rules, information. Reality is just a massive pile of raw Lego bricks, and the laws of physics are the instruction manual.
Right.
If you can build a synthetic machine capable of processing all that underlying information, you crack the code of the universe.
I have to push back on this worldview a little bit because it sounds, honestly, incredibly reductive. Saying my physical body, the coffee I'm drinking, human emotion saying it's all just data to be processed, feels like we're stripping away the human experience and treating reality like the Matrix.
Well, it is an incredibly arrogant worldview.
Yeah.
But from a functional standpoint, it is the exact philosophy driving elite AI research today. To Hassabis, biological life is just an information processing system resisting entropy.
Right.
The human brain is a meat computer, and consciousness is basically a complex, self-referencing loop of data. So the logic follows that if an organic machine can render reality, a silicon machine can be taught to do exactly the same thing.
Okay, so armed with that philosophy, he sets out to actually build the silicon machine. In 2010, he co-founds DeepMind with Shane Legg and Mustafa Suleyman, and they pitched Peter Thiel, who backed them specifically because aiming for artificial general intelligence AGI was considered completely absurd at the time.
Totally anti-consensus.
Yeah. And Elon Musk also invested, though the sources note Musk did so partly just to keep a watchful eye on technology he viewed as an existential threat.
Right. But the first scientific hurdle they faced was redefining the goalpost. Shane Legg argued that the Turing test was a terrible benchmark for intelligence.
Interesting. Why?
Well, because to pass a Turing test, an AI often has to pretend to be flawed. It has to simulate a math mistake or a typo so it appears human to the judges.
Which completely defeats the purpose of building an optimized superintelligence.
Exactly. So Legg redefined true intelligence simply as an agent's ability to achieve goals in diverse, complex environments. And to test this new definition, they didn't use chatbots. They went back to Hassabis's roots and used 1980s Atari games.
And this is the moment they achieved their massive technical breakthrough, because they combined two separate branches of AI, deep learning and reinforcement learning.
Right, and the mechanics of how these two branches function together are critical here.
Yeah, break that down for us.
So, deep learning excels at static pattern recognition. It acts as a black box that observes millions of images until it can mathematically identify the pixels that make up, say, a cat. But it doesn't take action.
Okay.
Reinforcement learning is the exact opposite. It requires an agent to exist inside an environment, taking actions, receiving a reward or penalty, and then adjusting its behavior accordingly.
Let me try to visualize this for you listening.
Sure.
Deep learning is like staring at millions of flashcards until you can perfectly recognize what a bicycle looks like from every single angle.
Right.
But reinforcement learning is actually getting on the physical bike, losing your balance, scraping your knee, and adjusting your center of gravity through trial and error. DeepMind basically figured out how to engineer a system that simultaneously recognizes the flash card and rides the bike.
And they engineered it by mimicking human neuroscience, which is fascinating. They implemented this mechanism called experience replay.
Oh, like dreams.
Yeah, exactly. In a human brain, the hippocampus processes your daily memories while you sleep, scanning for patterns to optimize future behavior. DeepMind gave their AI a digital hippocampus, allowing it to take massive chunks of global gameplay data offline, review it, and learn from it retroactively.
Wow.
They also split the neural network architecture into two distinct parts: an impulsive player network acting like the human basal ganglia, and a calm coach network acting like the prefrontal cortex, evaluating the long-term viability of the moves.
And the result was that famous 2014 demonstration, playing the game Breakout. They fed the AI raw pixels and the score, and literally nothing else, no rules.
Nothing.
Within hours, the AI figured out the dominant strategy of tunneling through the side of the bricks to bounce the ball endlessly over the top. In a submarine game, it learned to occasionally surface for air, which proved the AI wasn't just reacting to immediate stimuli, it was actually planning ahead.
It totally shocked the industry. But, Atari games are mathematically constrained. The rules are rigid.
Right.
If DeepMind wanted to prove they were building a stepping stone to true age and I, they had to conquer an environment that relies on a uniquely human trait: intuition.
Which leads them to Go. And by this point, Google has acquired DeepMind for $650 million. So with that massive computational backing, they target the ancient board game of Go. And Go isn't just difficult. The scale of it fundamentally breaks traditional computing. There are 10 to the power of 170 possible board states, which is exponentially more than the number of atoms in the observable universe.
So you cannot use a minimax algorithm or brute force calculation in Go. The decision tree is just too wide. Human grandmasters, they don't calculate 50 moves ahead. They look at the topological shape of the stones and they just feel the right move. So the question for Hassabis was, how do you code a gut feeling?
So DeepMind trained their AI, AlphaGo, on 30 million human moves. But the architecture is the really fascinating part here. They built two distinct neural networks.
Right.
First, they had a policy network that acts as a screener, basically suggesting a handful of moves that intuitively look promising. Then, a value network that acts as a judge, estimating the mathematical probability of winning from those specific positions.
And they combined those two networks with a Monte Carlo tree search.
Okay, what does that mean in practice?
Well, instead of calculating every possible future, the Monte Carlo search rapidly samples random simulations deep into the future, but only down the paths suggested by the policy network.
Ah, I see.
It gathers the statistical win-loss ratios of those random futures and feeds those probability weights back to the present moment, which allows the value network to make a highly informed, quote-unquote, intuitive decision.
So it's kind of like, think of the policy network as a squad of elite scouts. You don't send them down every single path in a dense jungle. You just send them down the 3 or 4 paths that actually look promising.
Exactly.
And then the value network is the commanding general who looks at those specific paths, while the Monte Carlo search runs thousands of rapid simulations of the war down those routes.
That's a perfect analogy, and this architecture culminated in the massive 2016 match against Lee Sedol, the legendary South Korean Go champion.
Right, the match the whole world was watching.
Yeah, and Game 2 produced Move 37. AlphaGo placed a piece on the 5th line of the board early in the game. To every human expert watching, it looked like a catastrophic glitch. The conventional wisdom of humanity basically dictated it was a terrible move.
But 100 moves later, that single incomprehensible piece served as the foundational anchor that connected the entire board and won the game. I mean, it proved the machine wasn't just regurgitating memorized human patterns, right? It was synthesizing entirely new knowledge that human civilization hadn't discovered in 3,000 years of playing the game.
It was a huge moment. Now, Lee Sedol fought back in Game 4 with Move 78, his famous God's move, which was this brilliant counterattack that actually exposed a flaw in AlphaGo's Monte Carlo simulations for that specific game. But AlphaGo still took the series, and the psychological fallout from that match was just profound. Professional Go players who had dedicated their entire existence to this singular pursuit realized they had been permanently superseded by a machine.
Which raises a terrifying question, right? If a silicon machine can perfectly replicate human intuition simply by recognizing patterns in massive data sets and running probabilistic simulations, does human intuition even exist? Or are we just biological meat computers doing the exact same subconscious math without realizing it.
Well, that tension right there is exactly why Hassabis views the world through the lens of infinite games versus finite games.
Tell me more about that.
The tragedy of the Go Masters is that they tied their entire human worth to a finite game. You know, a constrained set of rules with a clear winner and loser. When the AI won, their purpose vanished. But to Hassabis, Go was never the goal. AlphaGo was merely a proof of concept.
Right.
The infinite game was taking that intuition machine and pointing it at the messy physical reality of the universe.
Which brings us to biology. Specifically, the protein folding problem, which is essentially the Fermat's last theorem of biology. It had stumped scientists for 50 years.
Right. So proteins are the microscopic machines driving biological life. They begin as a one-dimensional sequence of amino acids, but almost immediately they fold up into these incredibly complex three-dimensional topological structures, and that final 3D shape dictates exactly what the protein does.
So if you think about it like a complex string of magnetic beads, the sequence of the magnets dictates how it snaps together into a highly specific lock and key mechanism.
Exactly.
And if a protein misfolds inside the human body, it fails to fit the lock, causing devastating neurodegenerative diseases like Alzheimer's or Parkinson's.
Right, and historically, determining the final 3D structure of just one single protein sequence required a whole team of scientists, years of lab work, and millions of dollars using things like X-ray crystallography.
But then DeepMind unleashed their AI on the problem. They called it AlphaFold. And in less than a year, AlphaFold precisely predicted the structures of 214 million proteins, which is virtually every known protein sequence on the planet.
It's staggering. And Hassabis then open-sourced the entire database. He just gave it to the global scientific community. It instantly changed the foundational speed of biology, accelerating drug discovery, the creation of new biological materials, crop resilience research.
And the impact was so undeniable that it actually earned Hassabis the Nobel Prize in Chemistry in 2024, which is at a speed virtually unheard of for the Nobel Committee because they usually wait decades to verify the long-term validity of a discovery.
But yet, just when Hassabis seemed completely unassailable, having conquered both constrained games and complex biology, this massive paradigm shift occurred in the AI industry that he completely underestimated.
Right, the rise of the large language model, the LLMs. And the ironic part here is that the underlying architecture powering this entire revolution, the transformer, was actually invented by Google researchers back in 2017.
Yep.
Because before transformers, natural language processing models had to read text linearly, word by word, left to right. This created a severe bottleneck in memory and context.
Exactly. Transformers solved this by introducing mathematical attention mechanisms.
Okay.
So instead of reading linearly, the transformer scans the entire data set simultaneously. The attention mechanism basically assigns dynamic mathematical weights to word relationships regardless of their physical distance in the text.
Oh, that makes sense.
Yeah, it builds a topological map of context, which allows the AI to focus its computational power only on the most relevant parts of the data.
But Hassabis initially dismissed the potential of LLMs. His entire philosophy, which was rooted in cognitive neuroscience and his work with reinforcement learning, was that true intelligence requires embodiment.
Right.
An agent actually must interact with an environment. He believed a system couldn't possibly understand the physical weight of a coffee cup or the concept of a dog's leg simply by statistically predicting text. Because to him, language was just a system of abstract symbols devoid of grounded reality.
But over at OpenAI, researchers like Ilya Sutskever championed the exact opposite philosophy. Sutskever argued that, quote, language is all you need. The hypothesis was that if you force a neural network to perfectly predict the very next word in a sentence across billions of pages of text, the network is basically forced to inadvertently learn the underlying physical and logical rules of reality in order to make that prediction accurate.
And the release of ChatGPT proved Sutskever's theory was incredibly effective. And it caught Google completely off guard. It triggered a textbook case of the innovator's dilemma.
Oh, totally.
Google had massive structural disincentives to release disruptive generative AI that might cannibalize their highly profitable search ad revenue. Whereas OpenAI, being a startup, had literally nothing to lose by burning down the old paradigm.
Right, and in response to this existential threat, Google actually forced a structural merger between their two rival AI labs, Google Brain, which had invented the transformer, and DeepMind, and they placed Hassabis in charge of the unified division.
So now we are looking at a literal arms race between OpenAI and Google. And to be clear for you listening, we are examining this impartially. The corporate drama is secondary to the profound philosophical and technical debate driving the actual engineering here, which is, can an AI truly reason about the world purely through statistical text prediction, or does it require environmental interaction?
Well, Hassabis answered that question with Google's new model, Gemini. By the time Gemini 3 launched, it was crushing industry benchmarks. And it did so by bridging those two philosophies.
How so?
Hassabis took DeepMind's legacy, the reinforcement learning and the Monte Carlo tree search planning they used in AlphaGo, and he injected it directly into the architecture of the LLM.
The mechanics of that integration are just incredible. Instead of the language model just statistically guessing the next word, it uses Monte Carlo planning to run hidden simulations of how the entire paragraph will pan out.
Exactly.
So if it realizes halfway down the decision tree that a logic flaw exists, it self-corrects before it even generates the first word for the user. It completely shifted LLMs from statistical parroting to global planning. And Google backed this architecture with their massive computational moat of custom TPU hardware chips.
And looking ahead, Hassabis is synthesizing all of these breakthroughs, LLMs, reinforcement learning, AlphaFold, into a singular mission he calls AI for science.
Because he envisions the next 10 to 15 years as a period of unprecedented scientific explosion. We are talking about using AI to design room temperature superconductors, optimize plasma control for cheap nuclear fusion, and eradicate complex diseases.
Yeah.
The sources even note his inspiration from sci-fi author I.N.M. Banks, envisioning this distant future where humanity builds Dyson spheres to harvest stellar energy and literally spreads human consciousness across the galaxy.
Which brings us directly back to the anxiety we discussed at the start of this deep dive. If you view the rise of artificial intelligence as a finite game, like if you are obsessing over who gets the job, who has the highest benchmark score, or who wins the corporate war, it is deeply terrifying.
Yeah, it feels like humanity is being replaced.
Exactly. But if you adopt Hassabis's view of the infinite game, the entire paradigm shifts. In an infinite game, the goal isn't to beat someone else or protect a fragile status quo. The goal is simply to keep the game of human flourishing going.
To continue uncovering the deepest mysteries of the universe.
Right. And in that framework, AI isn't a competitor replacing us. It is the most powerful tool humanity has ever built to help us play the game better.
It is the ultimate tool for decoding the raw information that constructs reality. And that leaves us with one final lingering thought for you to mull over. Hassabis built his empire on the belief that information is the base code of the universe. But if we are currently building AI systems capable of perfectly decoding and rewriting that information, from the biological proteins in our own bodies to the atomic structure of new synthetic materials, at what point does artificial intelligence stop being a tool we use to study reality and start becoming the reality we actually live inside of? Take that thought with you today.